multiplying monomials into polynomials. Basically what's happening here is the distributive property. So we have 5a squared, that is a monomial, and you are going to distribute into this trinomial here. So draw those arrows representing multiplication. Remember the product of powers rules. When they have the same base, you add the exponents. So my first step in this problem would go ahead and I would distribute 5a squared into negative 4a squared. When I multiply that out, multiply your numerical values and then multiply your a's. Now a's have the same base, so I would add my exponents. A to the second times a to the second would give you a to the fourth. So I would get negative 20a to the fourth. Next, distribute 5a squared into 2a, and then distribute 5a squared into negative 7. So I just drew my arrows in to represent that I'm multiplying and distributing into each of those terms. And when we distribute 5a squared into 2a, we get 10a cubed, and 5a squared into negative 7, we get negative 35a squared. Same situation here. Go ahead and distribute negative 6b cubed. So I'm distributing negative 6b cubed in each one of those terms. So I'm multiplying a monomial here by a trinomial. Negative 6 times 3 is negative 18. B to the third times b to the second, same base, add exponents, so I'd get b to the fifth power. Negative 6b cubed into a 4b. Negative times a negative is a positive, so I get 24b to the fourth power. And last, I need to distribute negative 6b cubed into negative 9. And I get a positive 54b cubed. Example 3, slightly different. You'll need to distribute in the first part here this monomial 3 into this trinomial. Then I'll need to distribute my negative a into this trinomial. After I'm done, I'll want to combine like terms. So we're going to go ahead and start off by distributing our 3 into that very first trinomial. There's my distribution taking place, so I'm going to multiply 3 into each one of those terms. I wind up with 15a squared plus 6a minus 15. Next, I'm going to go ahead and distribute my negative a into the second trinomial. There's my distribution. When I distribute my negative a, I get negative 6a cubed. And then negative a into 2a, I have negative 2a squared. And negative a into a negative 4 would give me a positive 4a. Next, looking at the terms here, I'm going to go ahead and write things in standard form. So I'm going to start with my greatest exponent first. In that case, that is going to be the negative 6a cubed. There is no other exponent that is higher than cubed, or there's no other degree higher than that. So I'll start off with negative 6a cubed. Now, looking at the rest of my expression here, I do have some like terms. My next degree that I'd write down would be squared. Well, I have a positive 15a squared, and that is a like term with negative 2a squared, giving me a positive 13a squared. Next, I do have some terms that have an a value, so those would be my like terms here. I would have a positive 4a and a positive 6a, giving me a positive 10a. Then I'd fulfill my expression there, putting down the minus 15 that I have not fulfilled there. So my answer, negative 6a cubed plus 13a squared plus 10a minus 15. That is in standard form. Last example here, example 4. I'm going to go ahead and let you try to problem solve and work through this problem. Again, here we are starting with a monomial, and we are distributing into this binomial because it has two terms. And we're going to take negative 2y and distribute into this binomial. So go ahead and distribute your 10z first. Pause the video, see what you come up with. Following my distribution there, 10z into 10y squared z to the fourth, I get 100 y squared z to the fifth. 10z into 5y squared z, I get 50 y squared z squared. Next, go ahead and distribute negative 2y. my distribution of negative 2y into yz to the fifth, I get negative 2y to the second z to the fifth. And negative 2y into a positive 4y gives me negative 8y squared. Next, I need to look at my terms and decide, do I have any like terms? And yes, I would have some like terms here. Here's a y squared z to the fifth. Here's a y squared z to the fifth. So those would be considered like terms. Combine those like terms. When I combine those, I have a positive 100 and a negative 2. That would give me 98 y squared z to the fifth. And then looking at my other terms here, I have a positive 50 y squared z to the second and a negative 8y squared. Those are not like terms. Well, if you look at it, this right here has a degree of 7. Here's a degree of 4. So if you were to write this in standard form, this would be written first prior to the negative 8y squared, because y squared, this has a degree of 2. Well, this has a degree of 4, adding those exponents together. And then last but not least is to go ahead and include your negative 8y squared. And this would be our answer for example 4 if you had to write it in standard form. When we do these problems, I'm not going to be too concerned when we have multiple variables to write in standard form. However, when we do have one variable, such as negative 8y squared, I expect that you guys write those in standard form. Other than that, when you come across multiple variables in this problem, I'm not going to be too concerned on where things go. This will conclude Lesson 4, Multiplying Monomials into Polynomials.